Light up signs! It begins! I got an incredible deal with a major esports personality, the Solid Steel Gamer. Her team contracted us with us to make light up signs that actually animate for her fans. As long as we keep the cost down, they're going to want tons of these to hand out in matches. It looks simple, just a few states. G. Alright. Click 0 and click 1 are simple outputs connected to display segments corresponding to a clicking animation. Drink 0 and drink 1 and drink 2 are simple outputs connected to display segments corresponding to a drinking animation. Control the display segments with fixed repeating signals as indicated in the verification chat. Alright, so we're gonna make a click and make a drink as far as I understand. So clicking, they're alternating on and off once per second. Drinking is doing some other funky stuff. Okay, alright, this is going to get a little bit crazy. We're going to even bring in the big boy here, just to give us a couple more outputs, I think. I think X-zeros and stuff can be used as outputs too. Okay, so we might not be able to use this guy here. We might have to use... we can definitely use this for the drinking one here. Or the clicking one. In fact, no. Pin 1. For the drinking one, we could possibly add stuff to other pins. I think these X's must be for transfers then. If we see if we can transfer data between these, yeah, we can do that. Okay, so I've got everything wired up here. We're just going to need to make some code here. This is going to be really inefficient. I bet there's going to be much better ways to actually do this. But we are just going to write a little bit of code here. So we're going to move 100 to P0. And move 0 to P1. Then we're going to sleep 1, and then we're going to move 0 to P0 and move 100 to P1 and then sleep 1. That's going to be U. And we just test this quickly. We should see that working correctly. Excellent. Then on this one, so drink 0 is going to be move 100 to P0, and then we're actually going to move 100, because you are doing drink 2 as well, move 100 to P1. Oh no, sorry, move 0 to P1. Let's do that instead. Okay, then we're going to sleep for 1, 2, 3, 4, 5, 6 seconds. Sleep 6. And then move 0 to P0, and then sleep 1 more second and move 100 to P1. And then sleep 2 seconds and move 0 to P1, and then sleep 1 second and move, and then, hang on, oh, I can't fit any more in! Oh no! Disaster! Okay, so we're gonna have to use a bigger guy. That's why these sizes matter. Okay, can I copy this? Oh, I can! Oh, that makes me happy. Okay, excellent. So let's get rid of you. We're going to move you across to here. That's P1. We're going to bring P0 down there, like so. Okay. So after you've slept 1, you're going to move 100... or after you've slept 1, you're just going to go back up to the top. In fact, I didn't really even need the bigger one. Oh well, that's fine. This guy, on the other hand, it is going to move 0 to P0, sleep for 6, move 100 to P0, sleep for 1, move 0 to P0, sleep for 2, move 100 to P0, then sleep 1, and then it should go back up to top. So this should now work. Excellent. Alright, we can see her drinking and sleeping and clicking and tapping and all the other good stuff. Very expensive circuit. Much more expensive than I intended it to be. But yeah, it's not terrible, I suppose. Yeah, we can bring the cost down a little bit, probably by using that smaller board there. Power usage we can bring down a lot, and production usage we can actually bring down a lot too. That's the most efficient. That's why these graphs are fun. You can see how badly or how goodly you did. Return to email. Ha! The end result looked great. I love the way it looks like the solid steel gamer is really clicking the mouse and drinking a soda. This is gonna be huge. Rubbish audio thing. So a contract came in to build a piece of audio kit. Sounds fun, right? I've always liked audio. This client promises that their little box will deliver crisp highs and booming lows, all in perfect balance. Then I see the advert happens to include the much vaunted algorithm that powers the thing. Go on, take a look yourself. I should mention I put a copy of said advert on your desk. Just look in the pile of papers marked supplemental data, since that seemed most appropriate. I should also mention that we still have to do this, as sad as it is. Works work and all, even when you have to help a dodgy American company market rubbish like this premium kit for audiophiles. So I'm assuming that paper's not on here. It's probably in my datasheets, so I could have a look at it if I wanted to. But let's open the design here and see what we can do. Audio in is a simple input connected to an audio source. Audio out is a simple output connected to an audio receiver. Maximize is a simple input connected to a switch. The signal from audio in should be copied to audio out, applying the harmonic maximization algorithm when the maximize switch is on. Look in the supplemental data section of the manual to find an advertisement featuring the harmonic maximization algorithm. Okay, I guess I do have to read the manual. We're going to use a big beastie here because I believe I'm going to have to do quite a bit of math. We're going to take audio in, we're going to take audio out, and we're going to need other stuff because we're going to need to transfer data between stuff as well too, I suppose. Alright, so let's get this, we're going to get you onto P0 and then get this to X across there. Okay, so I'm just going to note this down here just so I can read elsewhere in the manual. Audio out equals audio, okay, equals, I know it's going to be an error, but whatever. It's doing audio in minus 50 in brackets multiplied by 4 plus 50. Alright, that's the algorithm that we're going to have to make happen here. I now need to learn how to transfer data between chips. So on this chip here, what we're going to do is simply test equals P0 to 100. If it's true, then we are going to go move 100 to X1. If it's false, then we're going to move 0 to X1. And then we're just going to sleep for 1. That's how that's going to function there. But now we need to do some audio magicness here. So, what we're going to do is test equals X1 to 100. If it's true, it's going to do a whole bunch of operations here to math the audio. If it's and then it's just gonna go whatever. Okay, so first, actually, what I do want it to do is move P0 into a registry. We're going to move it to DAT. Okay. Then we're going to do the test here. And then we're going to move dat into P1. So if this is not pressed, this is going to move P0 into dat and then move dat into P1. Okay. If this is true, we're going to have to do that algorithm, which is a whole bunch of nonsense. So it is true. What we're going to do is move dat into AC, which is kind of like a working registry. It's where all the math takes place. We are then going to do sub 50. So that's in the brackets there. It's going to take 50 away from ACC. We are then going to want to do the multiplication. So we're going to want to do mol 4. That will multiply ACC by 4. We are then going to want to do whatever that last piece of the algorithm is here. I do need to scroll down to find it and check it. Plus 50. Okay. So I think that is... I'm going to have to scroll back up to my freaking reference. Oh, it's just add 50. That kind of makes sense. So what I think we're going to do then, instead of doing AC, we're just going to do this into ACC. Then we don't need to move the data into ACC. And then move ACC to P1. This should, I think, work. Simulate. Part not sleeping, blocked on read. Okay. So let's reset here. Let's just throw in a sleep 1 at the end. Hey, look at that! It's a-working! That makes me so happy. There might be more efficient ways we can have done this, but it actually genuinely works. I wasn't entirely expecting that, but okay, I'm happy. Yeah, we can bring that production cost way, way, way down. And power usage pretty far down too, actually. We're in, like, the top percentile there for production cost. Oh well, that's fine by me. Holy crap, this thing is awesome. I hooked one of these babies up to my stereo at home, and it blew the speakers clear off. Does the job, no question. Amazing. Alright. Self-driving cars stuck in a loop. A rogue loop is defined by the court as a state where a self-driving car appears to disregard humans and continues to drive around, refueling itself when necessary and ignoring orders to stop. What? Bring out the Baron. The Baron von Schnaps is in the house, y'all. I was out drinking last night and met someone from the company that owns this brand. There's a drinking game they're promoting that's hella fun and off the rails. I made a deal to supply them with a little personal scorekeepers they can give away at their events. Wait, what's the game? What counts as a point? What would be a foul? Surely not individual drinks. I don't remember the actual rules. Haha, create a working design for this prototype. Alright, create something that we don't really know what does. Point and foul are simple inputs connected to buttons. Display is an XBus output connected to a numerical display. I guess that's this thing. The counter should keep track of a count starting at 0 and constantly updating display with the current value. When point transitions from low to high, the count should be incremented. When foul transitions from low to high, the count should be decremented. So this is displaying our various outputs, and this is displaying our various inputs. Okay. So I've been thinking about this for long enough that the game has actually updated. We now have a new notes part. All these parts you can actually use now. They're just not recommended. But I think maybe I have this done now. So we're going to simulate. Part not sleeping, blocked and right. See, I don't know what that error means. Okay, so I think this... Hang on, we need to reset here. I think this needs to sleep until it has data to read. Problem is, if we do that, I don't know if it's going to mess up what I have planned here as a program. Let's simulate it and see what happens. Yeah, see, it's getting some right, but it's getting some wrong. So if we advance here, that should put us right at 0 time. If we advance, that's all cycled through. This is displaying nothing when it should be displaying 0. Now it should have moved this here, but because it's sleeping, it didn't move it. So, if we take this line, luckily you can actually copy and paste in these, which is wonderful, and move that up to there. So now if we advance, so it's already moved one bit of data across. If we advance again, okay, it's still good. If we advance now, it should read 1. Because this should go through, push 1 to here. Yeah, so that's pushed 1 to there. So that means it's got data from X1. It never had data from X1 before, so it's actually cycled... Well, has it? Or is it just waiting for data from there? If we advance again, yeah, it does go back up to the top. Okay. Advance again, it's good, but now it should go down to 0. Okay. 0, 0, 0, 1, 1, 1, 0, 0, 0, 1, 1, 1. Now it should go up to 2. Do we have this? No, it started to fail up there. Why? Oh, it's so frustrating. Okay, so up here it's good, and then it goes down to 0, and it knows how to do that. Now, I think the problem is when it becomes... It's getting 3 pulses from the first one. I think that's where the issue is going to be. So if we advance, we get 1. Then it should stay at 1. Now we should get 2. But this is down here waiting for SLX from X1. So it never gets that data. Because at that point it's waiting down there. How can I get it to wait up here instead? I've rewritten the code so that it should only be listening to X0 now, so we don't have to worry about it fighting against 2 different X buses. So now if we advance, it's not doing anything because it's not putting 0 in right away. So if we, as the first thing, get it to move ACK into X3, so then it's good. But then it's not good. That should be 0, but it's incorrect. What? Whoa, 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 whoa. Why is that incorrect? Part not sleeping blocked on read. Okay, I think we can get one sleep. I think we can do one test command. If we test if this is equal to 75, okay. If it's true, we're going to add 1. Oh no, we're going to test greater than x0 75. If it's true, then this is true, so we're going to be subbing 1. If it's false, then we're going to add 1. If it's equal to, I don't know what it's going to do. So let's check the reference manual. Oh, I'm so excited. Okay, right. So, we're going back. We're going back. We are going back. Okay, these should both give a signal at the same time. It's either going to give that it is 1, in which case it will be on, or it's going to give that it is 0. One of those will happen every second. Guaranteed. Move 0 to x1. Okay. So then, this is going to sleep until it gets data from x1. Once it has data from x1, it should have data from both, because both of these are running exactly the same code at exactly the same time. And they're both always giving a signal. So what we're going to do is test compare, so TCP, x0, x1. Now, if x0 is greater, it will be true. Okay? And plus instructions will enable. So in which case, point is true and foul is false. We are going to add 1. if x1 is greater than x0, in which case foul is true and point is false, we are going to be subbing 1. Okay, and that's subbing ACC. And then, if they are both true, then everything is disabled. Nothing will run. This should work. But I've said that every time. So we're going to advance. Okay, we're good, we're good, we're good. And because if both are true, and if they're equal to each other, then we don't need to worry about anything. It's going to add a point, then subtract a point. It doesn't count for anything. 2, 1, 0, 1, 1. This is where we started having issues before. 2, 3, and then back down to 2. Oh, I think it works. Oh, thank the Jesus. But I think we had a brief failure at the start here. Actual was 0, 0. That doesn't make any sense. But if we put the move at the end, it's not going to put 0. Oh, no, it did put 0 in. Okay, yeah, because it's going to be testing every... Okay, yes. Right. Right. I frickin' did it! I frickin' did it, guys! Oh, it's been bloody days. There we go, we can actually speed up the simulation. Zoom, 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 zoom. Alright. Our production cost was much higher than it needed to be. Our power usage was much higher than it needed to be. And our lines of code was much higher than it needed to be. I was really bad at this one, but I bloody did it. Thank God.